Okay, so let's start with the presentation. Can you all see the presentation? Everyone?
Yes, ma'am.
Yes, ma'am.
Right. And you guys can just call me Shivani. You don't have to call me ma'am. Okay. So this presentation was prepared before NFHS 5 came out. But I mean, more or less, the idea is the same. So I'll be continuing with this presentation itself. And what is NFHS dataset? It is also called as Demographic and Health Survey. This is conducted by Ministry of Health and Family Welfare, and it's coordinated by IIPS, which is International Institute of IIPS Population Sciences, yes. And it is funded by USAID and UNICEF. Now, IIPS office is in Mumbai, and Ministry of Health and Family Welfare, you all must know. Now, this is adopted from the DHS program, which is a global program in which you have to follow a certain specific set of rules, norms, questionnaire, and so that to enable comparison across various countries. Now, this DHS program, what it does, it targets the countries for analyzing the public health, primarily the public health of the state of the country. It's a unit level sample survey which covers approximately 6 lakh households from all states and union territories. In the case of India, of course, it is NFHS. So DHS is the broader umbrella body, and for India, we call it National and Family Health Survey, NFHS. Okay. Now, NFHS, as I said, covers approximately 6 lakh households, and the sampling is done so that it is reflective of the entire population. And I'm sure you guys must know the concept behind sample and population. So the idea behind sampling. So yeah, so this survey provides information on population, health, and nutrition. And until now, there have been 5 series, starting from 1992-93, then 1998-99, 2005-6, 2015-16, and the latest one is 2019 and 21. All right. Why can't I just... Okay. Yeah, so the objectives of the survey is to provide estimates of fertility, practice of family planning, infant and child mortality, maternal child health, utilization of health services, and there are many more added dimensions to it. One dimension would be the sun preference. I'm sure you guys must are aware of. So there are a lot of added dimensions to the survey, but yeah, majorly you're concentrating on health, fertility, practice of family planning, health indicators of the country, and so. So yeah, this provides you data on health and family welfare and emerging issues in these areas. One such emerging issues I just mentioned is, let's say, the sun preference. Okay. Now, it's very essential for anybody who's starting to work on data is to understand the design of the sample. And, probably some of you might start to do PhD after masters. Some of you might be interested in research. In that case, you might have to design your own sample, right? So designing the sample and knowing how your sample looks like is very essential for you to further incorporate into the analysis process and to further design your objectives and see whether the two can be mapped. So the sample in NFHS consists of the following things. The first is sample frame. So let me just give you a brief idea, understanding of these terms, which will be used when I'll be explaining you the sampling design. Now, first is sample frame. What is sample frame? It provides a complete list of clusters slash PSUs. PSU is primary sampling units slash EA, enumerating, I don't remember what E is. Yeah, so let me just check what EA is. I simply forgot what EA is. Yeah, enumeration areas. So E is enumeration and A is areas. Yeah. So it provides you a complete list of clusters or the primary sampling units or enumeration areas, following which is the step of stratification. Now, stratification, as you might know, is that you divide the population into stratas. And what is stratas? Stratas is your homogeneous subgroups. In this case, our first stratification unit is based on the rural or the urban area, whether the area is a rural area or a urban area. So you're actually dividing the population based on rural and urban areas. Okay. Then the next is to decide and to decide about the sample size. What sample or how many units you want to sample from that particular cluster or from that particular village. So yeah, deciding on the sample size is the next step. In India, as I said, 6 lakh households are sampled, and this includes your ever married women of age 15 to 49 years, men of age 15 to 54 years, and urban and rural regions of all 29 states, 7 UTs, and 640 districts. So yeah, starting from NFHS 4, I guess you have district level data as well. Yeah. To give you a quick brief on what we just discussed, let's take this example of a hypothetical country. This green is the hypothetical country that we are talking about, and the brown one is the hypothetical region which consists of our population at this point. Okay, so let's say I want estimates for this hypothetical region. All right. So the next step was to decide on to have your sampling frame. Sampling frame, what I said, is a list of all the clusters or enumeration areas or PSUs, right? Now here, this region has these clusters. Okay. 1, 2, 3, 4, 5, 6. And again, in these clusters, you have all the information about everything, all the households. Since it is a household level survey, in each clusters, you have information on number of households. And please interrupt as soon as you have a doubt or anything if you don't understand any of the things. So yeah, this is your sampling frame. Sampling frame is a list of all the clusters or all your enumeration areas. And this is how it looks like. You have a list of area 1. It has 114 households. And in that, you'll have the details of the household as well. Household number 1, this. Right? The next step is stratification. And what was stratification? It was stratifying on the basis of rural or urban areas. Now here, let's say your red comprises of rural and blue comprises of urban. So now you have stratified those clusters or the entire region based on the region, the areas, whether it's rural or whether it's urban. So this is your stratification step. Yeah. So how is sampling done in the case of NFHS? The first is stratify the sample. The first is stratify the sampling frame by geographic area, which was your, again, rural and urban areas. The second is select clusters from each strata. So from each red areas and from each blue areas, you choose the clusters. Okay. From those clusters, you do the sampling. You list household and then you select the households. This is broadly and in a very simpler way, I have explained that how the sampling is done. Of course, when you are choosing the households here in this step, there's a certain design of sampling being undertaken. It's yeah. So, but in a very simpler language, in very layman terms, this is how you can understand how the sampling is being done. Any questions until now? Okay. So, as I said, the stratification is done on the sampling frame. Your sampling frame is 29 states, 7 UTs, and 640 districts. Then the stratification is urban and rural within is done on the basis of urban and rural areas. Then there are 6 equal substratum, within each strata so that you can include SC and ST population. As I said, it has to be representative enough. So you want estimates based on each characteristic, to have gender. Is there any question? Okay. So
Ma'am, what do we mean by 6 equal substratum to include SC/ST population?
yeah, so within the broadly what it means is that within the urban and rural areas, you attempt to have, so the idea is to have SC and ST population included in the sample, right? Now those SC and ST population are specifically concentrated in certain areas, right? So if you can just go Google up and check the internet. Let's say ST population is majorly in the northeastern side, and then for SC, I think UP, Bihar, Madhya Pradesh, they have majorly SC population, right? So from those urban and rural areas, because you want SC and ST population both in urban and rural areas, you're creating further substrata. So the first layer of stratas was urban and rural. The substrata is SC and ST. All right. And to further delve into the sampling design, I can always share the document. This is the broad idea. So you just need to have the broad idea. Okay.
All right, ma'am.
So the sample size is 6 lakh households, somewhere around 6 lakh household. I think in 2019-21, the households have increased. Of course, the data is increased in the coverage. This was for 2015 and 16. Now, yeah, for women, of course, you want to interview women and men. The women, the age is 15 to 49 years in 2015-16. I'll have to check what it is in 2019-21. But yeah, again, for any data sets to see what is the target population, you'll have to read the report. The report of the data set has the information. In 2015-16, women of age 15 to 49 years were included. I need to check, as I said, it might have increased. You might have increased the women, might have included women of older age. But yeah, in 2015-16, this was the case. And men for 15 to 54 years. And it says out of 22 households randomly selected from each cluster. Okay. So let me just go back to my, 1 second. I'll just show you. Yeah, I had downloaded a report for you guys, and I'll just show you how you can always access the sampling design in each report, which will give you a more accurate idea of what that particular data set has done and what is the coverage of that data set. Here, 1.2 sample design. Can you all see? Guys, can you all see the screen?
Yes, ma'am.
Yeah. So as you can see in NFHS 5, it provides information for 707 districts, 28 states, and 8 union territories. It says a uniform sample design, which is representative at national, state, union territory, and district level, was adopted in each round of the survey. As I said, each district is stratified into urban and rural areas. So here, the district level was, having a list of the district comprises of your sample frame, right? Then each district is stratified into urban and rural areas. Each rural stratum is sub-stratified into smaller substrata which are created considering the village population and the percentage of population belonging to SCs and STs. All right. And then they say within each explicit rural sampling stratum, a sample of villages was selected as PSUs. And then again, within each urban sampling stratum, a sample of census enumeration blocks was selected as PSUs. So this is about the step as how you are selecting the primary sampling unit, which is village in the case of rural and blocks in the case of urban areas. In the second stage of selection, a fixed number of 22 households per cluster was selected with an equal probability systematic selection. Okay, as I said, there will be a proper sampling technique used in the last step as well. So systematic selection. Are you aware of this probability, systematic probability, where you just list the household and then decide, let's say, picking up every third household or every fourth household. Are you aware of probabilistic and non-probabilistic sampling designs or technique? Heard about it, studied it?
No, ma'am. No, ma'am.
Okay, so random sampling is there. You know about random sampling?
Yes, ma'am.
So random sampling is what? It is probabilistic sampling in which you assign a fair and equal chance to each element in the sample to be selected, right? Or in the population to be selected in the sample. That is your random sampling, right? Yes. So the idea is that you're randomly selected such that each element in the population has an equal and fair chance of being selected. Correct? That is random sampling. It's probabilistic. You're not really using your own bias while choosing the sample. Are you guys getting it?
Yes, ma'am.
Yeah, so simple random sampling is one of that technique. Then there is systematic sampling, and you can probably read about it later. Systematic sampling, what they have done here is that, let's say you create a list of every element in the population, and from that list, you decide that you will pick, let's say, every alternative household or every fourth household. Okay, this is systematic sampling. Again, it is probabilistic. You're not really using your own bias, and there's a probability attached to each element of being selected. Correct?
Yes, ma'am.
Yeah. So as I was saying, this is the sampling design, and of course you can read more about what kind of information is being captured here in this data set. Like here it says NFHS 5 was designed to provide information on sexual behavior, husband's background and women's work, HIV AIDS knowledge, domestic violence, and so. Then you can have, further information about sampling design again in the report. So yeah, this is how you can learn more and more, and you can learn more information which is going to be essential when you start working on the data set from the report itself. So be it NFHS, be it NSS, be it any data set, any publicly available data set, you can always you have to go to the report to access information about the sampling design. I guess there's some question. Um, how did we come to 22 number of households for interviewing from 6 lakh? No. 22 is from each cluster. It's not 22. So when you interview 22 from each cluster, you can arrive at a figure which can be greater than or less than 6 lakhs. Yeah. Okay. Let me just share my screen again and I'll go back to the presentation. and I will not be able to see your doubts, so it's better that you unmute yourself and ask right away. Okay, I hope the idea and what the dataset does, the sampling design and everything, the precursory information, I hope that's clear. Is there any doubt until there? Okay. So moving on.
Ma'am,
Yeah, yeah.
ma'am, can you please go back to the previous slide?
Sample design.
Yes, ma'am.
Yeah.
Ma'am, it's written 6 equal substratum. Is it something related to the weights that will be assigned to each substratum? Something like that.
What kind of weight? I'm sorry, what weight? So okay, you can
Ma'am,
tell me, yeah. What do we understand by weight? I need to know what is your understanding of the weight.
ma'am, there is certain weight that is being assigned to the categories of each variable. So, is it something like each substratum would be having equal weight or maybe different weights?
Okay, so if you're asking about the question in terms of assigning weight so that it is representative to the population, if that's the question, is that the question?
Yes, ma'am.
Yeah. So, okay, again, the weights are assigned based on a very specific calculation, and I cannot really comment at this stage that whether it's equal or what it is. It's a completely different process on how the weights are calculated. Okay, and the weights are not calculated stratum wise, it's calculated like for per unit. So there's a specific file and there's a specific procedure on how the weights are calculated. And I think, of course, what you are saying, it comes from the broader category, from rural, urban, then SC/ST. But again, there's a very specific process to it. I cannot comment about it, whether it's equal or whether it's not at this stage. I'll have to go and read about it. Yeah.
Okay, ma'am. Thank you, ma'am.
Okay. Shall we move ahead? Right. So next is working with the data. As I said, the first step is selecting the survey for the analysis. Let's say we are working with NFHS, and while you're working with NFHS, you should know the selection of the survey again is based on what is your objective. So if your objective is to calculate health statistic or say poverty, then and then you know that what kind of information this particular survey will provide me, and therefore you choose the survey. So again, to select the survey, you need to know about the survey. You need to know about the information that it will provide. And again, the sampling design, how representative it is and everything. Okay. Of course, the survey that is provided by the government, NFHS or NSSS, you don't have to think about the representativeness. But in other cases, yeah, that is one of the major criteria. All right. The next step is to review the questionnaires. Of course, now you have the data set. Let's say you've downloaded a data set, you have chosen the survey, you have the data set. You need to know about the questions that were being asked and see whether those questions are aligning with your objective. Okay. So if I want to know about say preference of the sun preference, what number of people or what proportion of people have a preference for a son. So I need to know whether this kind of question is included in the survey data set or not, right? Or if I want to know about the behavior of the mothers when they are taking care of their child, like what kind of supplements are they providing, whether they have what kind of behavior they had when they were pregnant, right? If I want to know about those situations, whether the child was provided with enough vaccines or the required number of vaccines. So if these are my questions, if these are my research questions, I need to know, I need to have those questions in the questionnaire that the survey is providing, right? And when I have the questions, from that, I'll be able to map what or where you can expect that question in that huge data set. So I'll show each and everything to you. But yeah, reviewing the questionnaire is the second step, and it's a very crucial step. Every time you're working with the data, you'll have your questionnaire right in the side of you, and that is how you proceed. Third is getting to know your variables. Once you have asked the question, now once the question is being asked, of course, this when I'll show you the questionnaire, you'll see that there are certain options. Like you have to tick, the enumerator has to tick those options. Let's say how many times have you visited this particular health center? Let's say this is a question. Now, one way is that they give you a number 1, 2, 3, 5, 7, 10. The other way is there are options in the questionnaire like less than 1 or 2 to 5, and so, right? Or there are questions like, yeah, what kind of health facility do you visit? Okay, now there you can have options such that you go to a government center or a private center or a non-professional center, non-professional individual, which can be your, dais and jhola chaps in the rural areas. So once you have a question, then you see the response, the kind of response that the enumerator can enter. Okay. And if it is if there are categories to that question, then those categories will be there as variables. So your variables are actually aligning with the questions that are being asked in the survey. Does it make sense? Are you guys getting it?
Yes,
Yes,
ma'am.
ma'am.
All right. The next step is data cleaning. I'll show you what does mean. And then step 5 is using sample weights, being very cautious about the weights. So we'll do it. Yeah, I'll show you, and it's probably a learning by doing exercise. Quick, quick overview about the questionnaires that are being asked or the survey schedules in NFHS. There's a household schedule, which includes or which has questions on the households. Then there's one for women, man, and a biomarker. Biomarker includes information on your height, weight, blood pressure, and so. All right. So the household questionnaires has information on socioeconomic characteristic, water and sanitation, insurance, number of deaths, demographics, and so. And then man and women, it has question on these, attitude towards gender, sexual behavior, nutrition, etc. As I said, biomarker includes your height, weight, hemoglobin level, blood pressure. These things are measured right there at while the subject is being interviewed and marked right there in the questionnaire. Okay. Okay. So, data cleaning, what does data cleaning mean? Data cleaning means that you are basically transforming your data set as per your need. So, for example, remember I told you that there might be a question like how many times have you visited this particular health center? Now, if in that question the answer has to be written down by the enumerator, and let's say the answer can range from 1 to 10, okay? And this is, let's say, in this particular week or in this month or in based on 6 month recall period. So the question is, I'll repeat, the question is, how many times have you visited a public health center in last 6 weeks, let's say? Okay, now the number of responses can range from 1 to, let's say, 50 or 60, right? Now there can be a case that the individual did not only go or refused to answer. Okay, in that case, the interviewer, the enumerator, is supposed to write that response, but while you are creating the data set out of it, you must be aware that the data set always have quantitative values, right? Even if it's a qualitative variable, it is assigned a code. You know that? Do you guys know that? Say yes, no, anything. That the data set is always quantitative in nature. Do you guys know that? By quantitative, I mean that there's always a number. Yes or no? Please say something.
Yes, ma'am.
Right? So even if it's a qualitative variable, you coded 1 or 2, right? So there's always numeric value in a data set. Now, if somebody gives a response that I went and I couldn't find one, or anything which cannot be written in number, in that case, a very special number is assigned. Let's say 9999. So this 9999 does not really mean that this individual went to the public center 9999 times, but it is actually a code for a response like don't know or didn't answer or any inconsistent response. All right. Now, your data set will consist of these values as well, and you have to remove these values. You have to take into account for these particular values while you are working with the data set, and that is precisely what data cleaning means. So if you just ignore, if you'll ignore these things, if you'll ignore these things, if you'll ignore the values that are assigned to these kind of responses, then of course you will not get the correct results. Understood? I'll show you. I'll also show you. Because let's just start with a example only. Let me just. Can you all see this data?
Yes, ma'am.
All right. So I'm starting off with a data set. Before that, let me just show you how you can download the data. You can see Safari, right? You can see the browser.
Yes,
Yes,
ma'am.
ma'am.
So let's say I start with writing download NFHS dataset. You'll have these following link. I'll suggest you go to this particular, the DHS program. Because from here you can get the dataset for every round. So as I click on this link, you see it's for, here it's 2015-16. Just write the latest. The report. I guess it's not uploaded on DHS as of now. See, I went to countries and here you have most recent surveys, India DHS 2019-21. Most recent data set, India standard DHS 2019-21. And as I go here, so see, I have the survey data set files. Birth recode, couples recode. You see, Stata data set. So these are the file format in which you can download the data set. Stata, SPSS, SAS, and so. So we'll be working on Stata. So what you need to do is you first have to register. Now it's a very simple step. You register, they'll verify, and once you are registered, you can easily log in and download the data set. Okay, you have to click on this particular link. Once you have logged in. Once you have logged in, you just click on these links, birth record, couples record, household record, the questionnaire, all right, individual record, children record, the entire set of files you'll have to download, and that will comprise of your data set. Now, the good thing about NFHS is it already separates the information on, say, birth, couple, household, man, women, and so that you don't really have to do that kind of thing. So that is one advantage of DHS, that it already provides you separated data sets. Okay. So the example that I'll be showing you is for undernutrition. Okay. What do we mean by undernutrition? Now, undernutrition is defined by let's say 3 set of indicators, one being stunted. Child's anthropometric indicators, one is stunted. What do we mean by stunted? That the child is not at par with, like, the child's height is not at par with his age. Okay, that is stunted. So whether if a child is stunted, that means the child is undernourished. Now the stunted variable is measured by height to age z-score. Okay, so now since my concern is, and since I want to calculate the child's health indicator, I'll go to this children's record file. Okay, so once I've downloaded, I'll open this children's record file, which is KR. If you all can see, IAKR. So once you have downloaded the data set, you'll see that the file is named something like this, IAKR. So KR is for children's record. Like HR is household record. Okay. So I have, because I've already worked with the data set, I've renamed it as undernourishment, but this file that I've used here is the child record only. The KR file, you can always check. So I'll just open NFHS 5 dataset here. Let me just show you how the data looks like. So yeah, this is case ID. There are these variables. Cluster number, household number. The first set of information is related to the sample, how they have mapped it. Okay. So yeah, even when the information is written like this in words, there's a code assigned as whatever was saying. One second. So this is how your data set looks like. Okay, so now I want to learn. Now I want to calculate. Let me just go back to this. Okay. So I want to see that, let's say my question in investigating the relationship between income and nutrition. All right, that's my question. Now for income, you have a variable which is wealth index in the data set. And this will occur to you only when you go through the questionnaire and check what kind of variable. So see, here you can read wealth index. This is a variable created by me, but let's take V190 and V191. So see, V190, the variable is wealth index combined, and it gives you the value categorized as this: poorest, poorer, middle, richer, richest. Okay, and V191 is just the score. So wealth index, as I said, it's an index created using a set of questions, right? And based on that index, they have actually created another variable in which they have categorized each household, whether it's poor or rich, whether it's a poor household or a rich household. And these are the 5 categories. So in order to explore the relationship between income and nutrition, I can take wealth index as a proxy. Right? Make sense? Yes, no.
Yes, ma'am.
Yeah. Now for nutrition, nutrition, the proxy is, let's say I'm exploring this relationship for child, the proxy will be the child's anthropometric indicators. Okay. This anthropometric indicators is defined by variables like stunted, wasted, and underweight. So stunted is height to age. Okay, similarly, wasted will be weight to age. Getting it? So let's just focus on stunted for today. So stunted is defined by, it's measured by height to age Z scores as per WHO standards. So what variable do I need here? I need the child's height, right? So if I search here, I see these variables which have height in this. Now, you'll see height in these variables, which is for variable which starts with the alphabet V, and you'll also see height in the variable which starts from the alphabet H, right? Which one is for the women and which one is for the child? That's the question. Like, which variable do you have to choose in order to have the height or the height to age ratio for the child? Now see, if you just look at this V419 and this is how you read the variable. Let's say I use the command codebook. Now codebook basically provides you a detailed information about your variable. It tells you the type of variable, the range of the variable, missing values, and how it is entered in the data set. Now this says entries in height or weight roster. If you look at the next variable here, V438. Let's see what it says. Codebook V438. Respondent's height in centimeters. Now understand here that when the NFHS is interviewing people, it's actually interviewing the adults and not the children, right? So if all the variables starting from V is for the respondent, it clearly means that this is not for the child, right? It says respondent's height in centimeters, correct? So the variable starting from V is not our concerned choice of variables. Here also, and then again, HW says child's height. Here, HW3. So we know that the HW variable is something that I need in order to calculate my statistics for the child. Okay. Now here again, if you see this HW3, 4, 5, 6, 10, 11. Now these all are for, I mean, at least 3, 4, 5, 6 includes height to age. And then there's HW70, height to age. Now, which one of these to choose? One way is you look at each of the variables, you read about each of the variable and then decide. The other way is that you go to the recode file. Now, what is the recode file? See, again, on the same website, the DHS program, I went to publications and recode manual. So the recode manual is again the manual on how the variables are defined. And again, this is similar for each country. So I've downloaded this DHS 7th recode manual and I guess, yeah, this is the manual. Standard recode manual for DHS 7. Now it has description on each of the variables. See V405. If you read about it, you'll get to know that this is for the woman. This variable is created from the maternity history by checking if the period returned after the last birth, if the woman is currently pregnant or not, and so. So this manual is basically providing you information on each of the variable. And now I'll go to the HW variable because I was concerned about that. So I know that HW is for the child and I need to see that which one is more accurately suited to my question. Yeah, see, here. section W44, height and weight and hemoglobin. And here it says the information included in this section comes from the data collected in the household questionnaire and transferred to the woman's level. If the height, weight, or hemoglobin measurement in the household questionnaire was restricted to selected households, then these variables are left blank for children where the variable in the household questionnaire could not be matched. And once I go to say HW3, it says height in centimeters. And again, this is for child. The base is all children born 0 to 59 months prior to the survey. So now my question was, let me just go back here. So I want to calculate stunted. I want to calculate the statistic for stunted, which is a anthropometric indicator for the child. And now I also want that my statistic should match with what is given in the report. So how will I approach this? I'll go to my report. I have the report, yeah. I'll go to chapter 10. Yes. So chapter 10 is about nutrition and anemia. And it states that stunting is measured height for age such that children whose height for age z-score is below -2 standard deviations from the median of the reference population are considered short for their age or chronically undernourished. So based on this description on how they are defining stunting, what you can do is you need to follow the information given here. So if what they say is height for age, then z-score. So height for age means that if you have height variable for the child and if you have age variable for the child, you divide height to the age. And the next step is to calculate the z-score. Okay, you know how to calculate z-score. You all have done statistics. And those who haven't done statistics, you don't really have to go in the technicality here because the data already provides you with the z-score. But just in case you don't have that in any other data set, you always have to follow the instructions that are given in the report on how the statistic is being calculated. Okay, so you have to calculate height for age z-score. It says that when the height for age z-score is below -2 standard deviation from the median of the reference population, then it is stunted. So I want to create the variable stunted using height to age z-score, and this is as per WHO standards. This is what our report also follows. So I'll go back to the recode file. Yeah, this is the recode file. I need height for age standard deviation. Now this is given here, variable HW5, height for age standard deviation from the reference median. And this is precisely what the report also said, right? Right, everyone? Are
Yes,
you
ma'am.
on the same page? Is there any doubt?
Excuse me, ma'am.
Yeah.
Ma'am, is it possible to combine two or more recode files because we might have variable of interests in the other ones?
Two or more, yeah, it is possible. Usually the data is designed or data is provided in such a format that you won't need it. But yes, in case you want that, you can merge. And that is something we'll do in the next class. So yeah, you can merge the two recode files.
Thank you, ma'am.
Any other doubt? Are you guys following up with what we are trying to do here?
Yes, ma'am. Ma'am, how do we select the proxy variable?
For this particular thing, stunting thing?
No, ma'am. We selected wealth index for income
Yeah, so you are
as
not
a proxy.
you're not really selecting, it's the only variable that is given to you, which can actually be a proxy for income. So what?
Okay.
So usually to measure income, the data sets have consumption expenditure. Okay, consumption expenditure is a proxy for income, or here wealth index. Now wealth index include whether the household has TV or whether they go out eating, and so this is how they have a set of indicators which combine together to form an index. You can't really have income, like, because income is, there are certain problems with recording income as well, like, because income could be variable for people who are not employed in a formal sector, right? So usually you have proxies for income, you don't really have income exactly mentioned in the survey. And it's again something that you can go back and read what are the problems associated with including income as income in the data set. All right, so the proxies that you have to select is based on the information that the survey gives. Here in NFHS, you have wealth index. If you go to NSSO, there they have per capita expenditure or household expenditure. All right, so these are the proxies that one can take for income. Okay, makes sense?
Yes. Okay.
Yeah. So that was that. Okay, now back to this stunting thing. As I said, when you look at the data set, you have HW5 height. Let me just show. Height for age, standard deviation, and this is from the reference median. HW6 says percent, if you can see, right? So of course, this is not our target variable. Then you come down and you'll see there's HW70 as well, which is also standard deviation. Height to age, standard deviation, new WHO. Okay, so as we know that we have to follow the WHO norm, the WHO, how WHO defines it, I think that my concern variable should be HW70. Okay, and I can also check it in the recode file. So here HW5 is height for a standard deviation from the reference median. And if I go down, HW70 is height for a standard deviation according to WHO. All right, so we know that in order to calculate the variable stunted or the statistic for stunting, I need to use HW70 variable. Is that clear?
Yes, ma'am.
Okay, great. So I'll go back to my data set now and I'll read about this variable. So HW70 is my target variable. It says 1201 non-missing values are not labeled and there are 21,831 missing values. And the variable ranges from -600 to 9998. Now, understand, we know, and once you'll read about this, we know that, and it's also there in the report, that when the z-score, height for its z-score is below -2 standard deviation from the median, you consider it stunted. Okay. Here, the variable is -600. It starts from -600. So what do we need to do? See, read here. The measures above were calculating using CDC, standard deviation, derived growth reference curves, and so. And then it says the measures are represented with 2 implied decimal places. That means to produce the actual measure, you have to divide the variable by 100. Do you understand this? So this is your data cleaning step. That the data that is entered, that the data that you have, the data being entered is with 2 implied decimal places. So when your report says that it has to be less than -2, but in the data starts from -600, it means there are 2 implied decimal places. So the first step for you should be to divide this data set by 100. So what I'll do is, let's say I'll do generate HAZ score is equal to, which is this variable divided by 100. Okay. Now if I go to codebook, my data is from -6 to 99.98. Now again 99.98. Go back to the recode file. Then it says if either the weight or height of the child is missing, then all the above measures are set to the missing code, which is 999 or 99999. Okay. If the weight is outside the acceptable range, it is coded as 9998 or this value. And this is what in my data set this 99.98 means. Are you guys getting it? So the data cleaning involves these steps, making it suitable to your objective. So what I've done is, the first thing I did is divided by 100. Divide my target variable by 100 is by creating a new variable. Now I have to account for these values as well. I have to remove these values, right? Otherwise I'll get incorrect estimates. So how will I do it? I'll do replace HZ underscore equals to dot if let's say if it's greater than 6, because the Z score will not be greater than 6, right? See, the lowest value is -6. Okay. Now I have created my HZ score as per the information mentioned in the report, which is here. This has to be below -2 standard deviations from the median of the reference population. So the next step is to create my variable for stunted. What I'll do is generate, let's call it stun is equal to 1. So a child is stunted if, what does it say? If the height to a Z score, HAZ, is less than -2 standard deviation. So this is my correct variable. If HAZ underscore, if HAZ score is less than -2. All right. Then replace. Understand that I'm creating a categorical variable here, a dummy variable. So replace stunt is equal to 0. If it's not the case, if the child is not stunted, okay, that means if HAZ underscore is greater than equals to -2. Any doubt here? Any doubt? Now let's just check all our 3 variables. HAZ score, HW70 and STUM. So see, your HW70 was 121, which means 2 implied decimal places. So it's 1.21. Okay. And if, as per our definition for stunted, if the child height for age z-score is greater than -2, then the child is not stunted, right? So here in the data browser, of course, this value is greater than -2, and this implies child is not stunted. So we have done the right thing. But here you see that when it's missing, your stunted variable is 0. When HAZ score and HW70 is missing, the stunted is again 0. So the stunted variable that you have created, you have not really accounted for these missing values. You have only accounted for the non-missing values. So what I'll do is I'll go back and I'll account for the missing values again. So I'll do replace stun equals to dot if HZ underscore is double equals to dot. So every time my HZ score is dot, my stunted will be a missing value. Okay. Now I have created my variable. This is my variable. I have assigned the child as stunted or not stunted based on his height to age z-score. Okay. The next step is to calculate the statistic and check whether I have done the right thing or not. Now here the role of weights comes into the picture. So I don't know whether all of you knows or not, but with each sample, because the idea of your sampling design, especially in case of the survey data set, the representative survey data set, is to map the figures with that to the population, right? You want an estimate for your population. In doing so, what you have to do is you have to create or you have to have weight. This is what your national representative survey datasets have, that they provide you with a weight variable so that when you apply those weight, which is you're actually multiplying each value with the weight assigned, so that it resonates to your population. Okay, that's the idea of weight, sampling weights. That means you want to resonate your sample with that to your population. In the case of NFHS, you have this weight variable in each of the recode file. In household file, it is labeled as HV005. In household member file, which is PR recode, it's again HV005. Women or children, it is V005. We are dealing with the children file. Even if you don't have this information, you can always just go to your data set and type weight. See, here it says women's individual sample weight 6 decimals. What does it mean? That the figure that you have to divide it with, I mean, it is implied with 6 decimal. Just what we did in the case of HAZ score, right? Check other variables, entries in height, respondents weight, and there's no other weight variable, the sampling weight variable that we want. So what I'll do is I'll generate weight. Let's call it WW because I've already created a weight when I was working. So let's call it WW, which is your V005. And now this is implied with 6 decimal places. So I'm dividing it with 1, 1, 2, 3, 4, 5, 6. 6 zeros. Now I have created the weight variable. The next step is to apply the weight. So I have my variable stunted and I have created weight. I'll just do the tabulation. Simple tab. Stunted. So what do we see? One is the number of children which are stunted, right? And the percentage is 35.47. Let's go and check it with the population, which is mentioned in the report. So this is level for child, level of child malnutrition. Stunted is low height for age. And if it is 5, it says 36. And our estimate is 35.47, which is acceptable. You understand? So I've actually created this basically gives me an affirmation that yes, I've done the right thing. 35 and 36. Okay, so now I'll stop and now you tell me whether you have any doubt before I proceed with a few more technicalities. Just tell me whether there's any doubt. Say yes, no, anything.
Hello. What did we do exactly in the weights part, which we did just before this?
Did I lose the connection, guys?
Yes, now you're audible.
Oh.
I was asking a doubt.
I was. Wait. Did you all, I mean, I don't know. Did I lose? Was it there the entire time? Firstly,
Yeah,
you guys
it
tell
was
me
in the
that.
entire time you left when you were asking a doubt. So it was there.
Okay, great. Tell
So
me what.
so I had the doubt regarding the weights part which you were doing. Uh,
Hmm.
so like what was that exactly and how are we going to use it?
Oh.
Or what was the use case of it?
Okay, so weight, as I said, it is required. You are actually applying weight in the sense that unit, each unit, there's a weight assigned that this particular unit resonates with this particular section or share of the population. That is what weight means, right? So the idea of weights is that you can actually have the estimates for the population based on your current sample. So based on these 6 lakh households, you're actually trying to project for the population. That is the idea for the weights, and the weights are being calculated by a very specific procedure. There's a specific file for it, and if you want, you can always, look up that file and see how the weights are being calculated. So applying the weights, you have these. Let me go to this data. So you have the variable weight. I'll just show you what weight means. So browse V005 and the variable that I have created. See,
Your
it's
screen is not sharing right
okay.
now.
Yeah, 1 second. So I have done what? I have done this. Browse and see. These are the two variables. V005, as I said, has 6 implied decimal places. So once I have divided it by that, you get these are the weight, which means this observation has this much share of the population. Are you getting
Okay.
it? So
Okay.
this is how you are actually assigning the weight. See, 2, 4, 0.7, and so.
Okay.
To apply the weight, you use this. You provide a square bracket and AW, PW. So no, these are certain things. Let me just, okay, I can't really do help weight in this system. It just crashes. But what you can do is you can go to help weight. Let me just show it on the Google. I'll show it here. So you have, I think, 3 to 4 options: AW, PW, FW, and there is IW also. And there's a specific file on how you can use what particular thing that you have to, what particular weight among these four you have to use while applying the weight in the data set. So when you want to calculate the frequency, the number of people in the population. So see, I'll show you here. So here, because I had applied AW, I'm getting the percentages, the correct percentages. But if I'll apply FW, just read what the frequency says here. It's 73,000,
Right.
right? Now, if I'll apply FW, okay, I'll have to. May not use non-integer frequency weights. So the weights have to be, in this case, the weight has to be rounded up. Generate WEIGHT weight 1 is equal to round WW. And I'll apply FW on the rounded up variable, which is weight 1. Any other doubt?
No, ma'am.
So what you guys can do, you can try this exercise at home. And other than this, other than stunted, you can try for wasted, underweight, or say anemia. Anemia among children, anemia among adults. The steps remains the same. Go to the report, read what the information they have mentioned, because whatever information they have mentioned, that's exactly the same thing that they will be doing while calculating the statistics. And follow the process, follow the information, try these things at home. Yeah, that's it. And in the next class, probably we'll do merging, and I can take some of the doubts that you might have incurred while doing these things. All right. Anything
Ma'am,
else? Yeah.
ma'am, will you be sharing these data commands with us?
I have, I think, used only 5 to 6 data commands, which is there in the presentation. I can send the presentation. This tab, recode, generate, replace. You guys must have done generate, replace, no?
Yes, ma'am. You've done.
So there's not much command. I've used the basic ones only.
Okay, ma'am. Thank you.
Share the presentation if you guys need. That should be enough. Anything else?
And ma'am, will the recording be shared as well?
You can ask Krishna so for that.
Okay, ma'am. Thank you.